impacting water resources significantly, as we all know. And to address this issue, the Indonesian government has implemented several conservation efforts and policy interventions. So today we are here to discuss these efforts and share our experiences among Asian countries, Indonesia, Japan, and China that have faced similar challenges. So we are very delighted to have one distinguished speaker with us today, representing the Ministry of Energy and Mineral Resources, MEMR, and he will provide insights from the government, decision makers, policy makers' perspectives on Jakarta's water environmental challenges, water resource management practices. While yesterday's academic centered around the scientific findings, scientific discoveries, and academic discussions on water resource management, I firmly believe examining the water environment from a governmental viewpoint is also equally crucial. So this can complement scientific research and discoveries, contributing significantly to sustainable water resource management. So today's agenda begins with our speaker addressing his presentation. And following that, we will hear experts from Indonesia, Japan, China for discussions. Finally, we will open the floor for questions, comments, and further discussions. Well, let's extend a warm welcome to our first speaker, Dr. Tat Setiawan, and the head of Groundwater Conservation Office, Geological Agency, MEMR, and he will share insights on the present condition of groundwater in Jakarta and the groundwater conservation action in Indonesia. So Dr. Tat Setiawan, you have the floor.
Thank you very much. Good morning, everyone. The Honorable Head of Center for Limnology and Water Resources, National Agency of Research and Innovation, Dr. Hidayat, and also Dr. Cynthia from BRIN, Dr. Akira Haima from Shiba University, Dr. Arianto Budi Santosa from BRIN, Associate Professor Guangzhou from Guangdong Ocean University, and Moderator Associate Professor Run Shenzhen from Tokyo University. And ladies and gentlemen, my name is Taat Setiawan from the Groundwater Conservation Office, Geological Agency, Ministry of Energy and Mineral Resources, Republic of Indonesia. I will presentation and explain my institution and its activity and regulation or management, groundwater management in Indonesia, and current condition of groundwater in Jakarta groundwater basin area. Sorry, I will share screen. Okay. Okay. Groundwater Conservation Office or BKAT, Balai Konservasi Air Tanah, was formed in 2013. The main task of BKAT is groundwater monitoring and land surface monitoring in area of Jakarta groundwater basin. And currently, the BKAT has additional tasks at Serang Tangerang groundwater basin, province of Banten. BKAT was formed in 2013. due to the issue of related to groundwater environment, such as land subsidence, the sinking of Jakarta issue, saltwater intrusion, and groundwater pollution. This is related to Jakarta as a capital of Indonesia with a population more than 10 million people, which has a very high stress related to groundwater. Uh, Balai Konservasi Air Tanah or BKAT, Groundwater Conservation Office, carried out at 220 location of groundwater monitoring, but at duct wells, production well, and also on monitoring wells. This activity is carried out to measure groundwater level, physicochemical of groundwater, and also take water samples for hydrochemical analysis in the laboratory. BKAT has been monitoring land subsidence at Jakarta groundwater basin, and land surface measurement are carried out every year using the GPS geodetic at 100 points PM. GPS measurement in 2015 to 2022 show a rate of land subsidence between 0.04 to 6.30 centimeter per year. Currently, there are around 50 monitoring wells that are still in good condition. BKAT has 23 monitoring well, and 14 of them have been modernized by changing non-contacting sensor equipment. Nah, in 2024, BKAT plans to add 5 monitoring wells on Depok district, one location on Tangerang Selatan, one location, and on Bekasi, 3 location. BKT also develop data information system. It is called as PASTI, pemantauan air tanah dan subsiden terintegrasi. PASTI is an online platform to provide real-time groundwater and land surface data that is integrated with automatic water level recording and global navigation satellite. The sensor transmit the signal to server, and data can be accessed groundwater level, groundwater quality, change in land surface, monitoring well data, and groundwater thematic map. Ladies and gentlemen, the geology of North Jakarta area. Geologically, the Jakarta groundwater basin is composed of alluvial vein deposit, the brown color. It is alluvial vein deposit. And then Banten tuff, that the pink color, and alluvial deposit, the green color. And locally, in the north part of Jakarta area consists of bed-rich deposit, the yellow ones. Currently, maximum drilling has only reached around 300 meter. The groundwater basin of Jakarta basement is estimated around 700 until 800 in depth. And around 9,000 years ago, this area experienced a peak rise in sea level. And around 5,000 years ago, the north coastal area of Jakarta, around 3 kilometers from shoreline, uh, was still flooded with seawater. Based on an understanding of quaternary rock deposit, estimated that land subsidence in Jakarta area due to tectonic is around 0.06 to 0.1 centimeter per year. Is relatively small. And Jakarta groundwater basin administratively include the entire of Jakarta province, uh, parts of West Java province, mainly in Depok City, Bekasi City, and also Bogor City, and parts of Banten province, on Tangerang Selatan or South Tangerang City. Hydrogeologically, groundwater basin Jakarta is divided into three systems, namely unconfined aquifer system or shallow groundwater system, generally less than 40 meter deep. And then the upper confined aquifer system, generally 40 to 140 meter. And then the middle confined aquifer system is generally 140 to 2000 to 150 meter. And the lower confined aquifer system more than 250 meter. The subsurface condition, as seen in the picture, so that in the upper part of the unconfined aquifer system, there is a thick sand and continuous layer of sand. But in the north part is thinner and dominant consists of clay. And for confined aquifer system, the aquifer is thin and the dominant layer is a silt to clay, dominant as aquitar and aquiclude. This is so that the confined groundwater potential in Jakarta, mainly in quantitative, is relatively low. How about the Jakarta confined aquifer system in initial condition? The picture show then based on data from dry well or dry well around 1003 until 1916 in North Jakarta and Central Jakarta, so that the confined aquifer has piezometric head, positive artesian well, between 1 until 5 meters above the local land surface. And how about the salinity of groundwater in Jakarta, both unconfined and confined aquifer? The groundwater salinity that in the north part of Jakarta, there is a brackish groundwater, but in unconfined and confined aquifers. In unconfined aquifers, groundwater with Higgs salinity, especially in alluvial rocks. The water tip, the water types change from south to north part of Jakarta groundwater basin, from calcium bicarbonate to natrium bicarbonate, and then to natrium chloride. In confined aquifer, the groundwater with high salinity is found at a distance less than 3 kilometers from the coastline. This is related to saltwater intrusion, which will be explained later. How about water type and groundwater quality? The analysis using aquachem and paper diagram. The paper diagram show the water type of Jakarta groundwater divided into 5 types. Uh, in unconfined aquifer, Jakarta show that the northern part of Jakarta unconfined aquifer system is NaCl, natrium chloride type, with so poor quality. This is related to a geological factor or geogenic factor in the form of rock type that dominant clay, which are deposited in a shallow marine environment. The rainwater dilution is not effective due to the rock dominantly composed of clay and sediment. The short part show that poor unconfined aquifer system quality caused by anthropogenic factor. This is indicated by the high level of nitrate and the salinization of chloride and also sulfate. The middle part show a good groundwater quality with water types calcium bicarbonate, magnesium bicarbonate, and also natrium bicarbonate. How about in the upper confined aquifer system? In the upper confined aquifer system, groundwater quality is generally good with groundwater type, calcium bicarbonate, magnesium bicarbonate, and also natrium bicarbonate. Poor groundwater quality in the northern part is caused by a saltwater intrusion with natrium chloride water type, and poor groundwater quality in the south part of confined aquifer system maybe could be related by lakes leaky from the overlying unconfined aquifer system. Maybe the apa well construction is damaged due to the old dry well. How about in the middle confined aquifer system, the deeper groundwater system in Jakarta groundwater basin? Groundwater is generally good quality with a water type calcium bicarbonate, magnesium bicarbonate, and natrium bicarbonate. There is a locally poor quality groundwater in northern part of middle confined aquifer system. It is maybe related to saltwater intrusion, white water types, natrium or sodium chloride. The results of analysis using a stable isotope show that the mixing of seawater or salt water with fresh water is around 10 until 20% at Kapuk area. Kapuk Kamal, North Jakarta, around 1 or until 3 kilometers from shoreline is the Haigos mixing around 21% the mix of salt water to fresh water, and gradually decrease in the south part of northern coastal area of Jakarta groundwater basin. How about nitrate concentration of groundwater? Uh, High nitrate nitrate concentration are found in unconfined aquifer system in the north part of Jakarta area. The red ones, the red color of the red color is concentration of nitrate more than the standard of Ministry of Health, and the green one the below of standard concentration of standard Ministry of Health standard. In unconfined aquifer system, uh, high nitrate concentration on unconfined aquifer system may related to the fact that the and the southern part geologically, the central of northern part mainly layers of clay. The clay sediment can reduce the concentration of pollutant. In the southern part, there are a high nitrate concentration of confined aquifer system may be related to the damage drill well resulting in leaks from the upper uh, aquifer system. Nah, regarding to groundwater abstraction regulation, there is an instrument for controlling groundwater extraction in the Jakarta groundwater basin, namely the groundwater conservation zone map. The map is made based on the level of decreasing groundwater level, confined groundwater level, compared to initial condition. The safe zone is the blue color. The safe zone is if the groundwater level decrease less than 40% of the initial condition. The vulnerable zone, the yellow color is zone if the groundwater level decrease between 40 to 60% of the initial condition. The critical zone is the pink color. If the groundwater level decrease between 60 until 80% of the initial condition, and the damage if the groundwater level decrease more than 80% of the initial condition. The maximum utilization in the safe zone is 34 meter cubic per day per well, and the maximum allowable discharge and on the vulnerable zone is 28 meter cubic per day per well, and maximum allowable discharge on critical zone is 18 meter cubic per day per well, and on the red zone or damage zone, groundwater extraction is not permitted. Um, Type of groundwater use in DKI Jakarta. Groundwater use in Jakarta has also experienced a very significant decline, especially from 200 9 until present. Of course, this is related to strict regulation on groundwater extraction, increasing groundwater tax mainly on 2010, the Jakarta Provincial Office uh, raising the groundwater tax and increasingly extensive drinking water supply system from Pamjaya, uh, sistem penyediaan air minum or water piping distribution system service and service coverage more than 65%. The uh, yellow color is unserved area, the white color served area, and the green color unserved area. Most people use groundwater in southern part of Jakarta area. Uh, Overlay maps of land subsidence and confined groundwater level of Jakarta groundwater basin in several locations show a correlation between subsidence and groundwater level of Jakarta groundwater basin. Several locations show there is a correlation and between land subsidence and decreasing confined groundwater level. The analysis of extensiometer and piezometer data from the period of 2001 until 2002 at BKAT office monitoring wells so that the decline in groundwater level contribute around 60% to the occurrence of land subsidence. GPS measurement by Abidin et al. 2008 show that the rate of land subsidence between 1 until 10 centimeter per year and 15 to 20 centimeter per year. But GPS measurement by BKAT in 2015 to 2022 show a rate of land subsidence between 0.04 to 6.30 centimeter per year. It is show a rate of land subsidence decreasing uh, the decreasing of rate land subsidence and the graph of land subsidence from 1990 to the present at the X monitoring well location, the manual monitoring well on the Jakarta PKAT office show a graph that has been sloping since 2011 and tend to be flat since 2022. It is so that the land subsidence in the north part of Jakarta is decreasing significantly. And the result of groundwater monitoring so that there is a gradual process of confined groundwater level recovery in various Jakarta groundwater basin area at rates of varying between 0.05 meter to 6 meter per year. But the uh, first part is still decreasing or lowering groundwater confined aquifer until 6 meters per year. Of course, this is a positive indication of the result of groundwater management in Jakarta area. This is the increase of confined groundwater level and also reduce rate of the land subsidence. However, we all must remain aware and continue to regulate groundwater use wisely and sustainability. Okay. Thank you very much. Good morning.
Thank you very much, Dr. Tats Setiawan, for your insightful presentations and valuable perspectives on the challenges faced by Jakarta's groundwater environment. Your expertise and contributions have shed light on the crucial aspects of groundwater environment in the region. Okay, now I would like to pass the floor to my colleague, Cui Ying, to moderate the discussion session.
All right. Thank you very much for Runsen of passing me the floor. And thank you very much for our first presenter, Dr. Tat Setiawan. So right now, I would like to invite our discussant to provide some insightful experience and also their backgrounds, their home country situations. And in addition, also multidisciplinary insight to add on these discussions. So first of all, please let me introduce our discussants today. The first discussants will be Associate Professor Guang Zejing from Guangdong Oceans University. And he's very experienced in astral science and also oceanography, and followed by Dr. Arianto Budi Santoso, and he is a lake scientist. So we believe that these discussions will be involve a multidisciplinary, like different field experience. So if you are ready, maybe Dr. Jing, you can start to share like how's the situations in China in comparisons with Jakarta situations, and perhaps anything differences or any kind of
Hello. Yes, thank you very much for the presentation and thank you very much for the inviting. So in my case, I do the how to say some of the hydrology and groundwater how to say study and research with Professor Onodera in Japan, and also now I also participate with some field survey with Professor Chen in China. And in here, so after I see the presentation, I see very interesting. And it has described so many parameters about the groundwater situation from the Jakarta area. For example, the southern mountainous area to the plain to the coastal area. And also it has many how to say data with very long time. So I think it's very important and also very interesting. And similar to China and Japan, so we also, for example, have the problem similarly, like the groundwater pollution. For example, we have the nitrate pollution, and also we have like the groundwater, how to say the over exploration, that reducing of the groundwater level and the land substance. So that problem also exists in China. Also, just maybe 1 week before I start to come here, the center city of my Zhanjiang city has occurred one land substance, how to say the accident, and one car just fall inside the hole. So I think this is like the similar problem with all the cities that face the water crisis, and we have to use some of the groundwater, so we have the problem. But I'm quite surprised to see the result that the land substance result is decreasing and nearly zero, I see about recently. So I think it's very good impact. And also for me, so I think some small differences between the three countries is the precipitation volume is different. So in Jakarta, I think very high, about 2,000 to 3,000 per year. So that one maybe provide much more, how to say, the groundwater recharge resources into this area. But in China, also in near my city is about 1,600 to 800. So a little decreasing. So we have to face maybe waiting for a long time for the recovery and for the groundwater recharge. And in Japan, I think a little more lower. So I think some differences of this one. And I see that you have some, how to say, data of the nutrient concentrations. And I think if there is some more data, for example, concern about other nutrient concentrations monitoring. So how to say, annually or monthly, is more better to consider the nutrient discharging from the land to the sea and maybe have some results and data to support the environmental impact in the Jakarta Bay. Also, now it's very hot, how to say, the topic is about the organic matter transported by the groundwater also. So that one is like a direct carbon transport. So that one will contribute like the global ocean carbon uptake and like the coastal maybe carbon budget and cycle. So that one is very interesting. And actually we have done a similar work in the Western Guangdong province, and we just measuring the, how to say, the dissolved organic matter in the groundwater and in the bottom of the seawater. And we can see some points is very good of the transport path. And that one is also similar to, I think similar to Jakarta because of agriculture and the hot temperature maybe enhance the organic matter decomposition from the soil. So that one also provide much more of the organic carbon, so resources. And also I see that you have divided the groundwater zones, different groundwater zones like the safe zone, recharge area, and some protected area. So that one also similar situation in China. And for the recharge, how to say, recharge zone or safe zone. So I'm not sure about the detailed action. For example, no factory, no agriculture, or no maybe aqua fish using in that area. I think maybe some similar situation. So if you can provide more information, I'll be very happy. And also I'm quite interested into the nitrate pollution content with much higher of 150 milligram per liter. So I think that value is quite high, and that one will quickly decrease during the transport process. So yes, thank you.
Thank you very much, Dr. Jing, for providing your insight over the presenter's contents and also the situations in China. So next, let's invite Dr. Arianto to provide your insight as a lab scientist in this issue.
Thank you very much for this opportunity. As you mentioned before, I'm a lake scientist, and I see this issue or this topic in relatively general view. So we heard from yesterday that there's a connection between land and the ocean, and then the connection goes through the inland waters, let's say the surface or to rivers and lakes probably, and then also through the groundwater. And then that connections, we might say that as the pipeline transferring, the pollutants in general, or all the biogeochemistry elements. And this pipeline is sort of active in a way where in every stage it will be processed, let's say. And then when it finds megacities, the situation might be different. And then Professor Onodera yesterday mentioned about his hypothesis about the 3-stage pollution states, where developing cities might have high level of pollution, and then in middle developed cities, the pollution will be decreased, and then in the very developed cities, the situation is totally different, where the pollution coming out from that city is totally reduced. And then that's what we see in Osaka Bay, where biological productivity there is declining because the the outflow of the nutrients is very low. Let's say that makes the Osaka Bay into oligotrophic condition, where change the situation where phytoplankton is not that much, and then the fish production is, of course, suffering from that situation. And then that's what we have to consider, where land and ocean interact, and not only the pollution or the pollutants that we are concerning a lot, but also the interaction between land and the ocean. And then that's where we have to meet between the managers and the scientists, and then we discuss how to meet in a certain level. What I mean is, let's say the yesterday issues about the Osaka Bay, where we are doing very well in managing the catchment, so that the pollutant flows to the ocean is very low. But on the other hand, the productivity of the ocean is, or let's say the coastal area is also dropping. So that's where we have to meet. I mean, the scientists and the authorities there to set a level where everything should be, in the fine tune, where the environment can also process very well, and then the local people there, at least, still can enjoy the nature. The nature has to offer, and yeah, that's where we have to discuss actually, and about the 3-stage pollution states. That graph. Does that hypothesis fit with our findings? I mean, does that only applicable for the one that we see today, or at least since this year's, from Japan, China, and Indonesia? And does that alternate the active pipeline that I mentioned before, where the land and ocean interacts, and then you have process in between, and then from in that pipeline, the transfer of biochemistry properties change a lot. And then when those megacities occur in the coastal area, how does that changing happen? And what could we highlight from all those findings in regard with the global nutrient cycles? That's a big thing that everyone here, as a scientist, want to hear or want to see actually. And then from the manager's point of view, I think it is very important to highlight that in terms of water resources, coastal health, and coastal productivity, what should we take out from what we discuss here? What I mean is, again, going back to the example from Osaka Bay, it's a very good example actually, and we find it as well in the lake. We manage our catchment very well, so that everything comes out from the land to the ocean is really controlled. But on the other side, the fisherman is crying a lot because there's no fish anymore, because we control the nutrients, we control phosphate, phosphorus, nitrogen to the ocean, and those elements controls the productivity of phytoplankton. So that's what we have to discuss actually. And from my experience in Jakarta, well, I don't have much research in Jakarta, but we know that Jakarta is very, under pressurized city where more than 20 million people, is it correct, lives in Jakarta? Not up to 20, 10 something million people lives there. And of course, water resources is
11
important issues.
11 billion people.
11 billion,
Around 11 million
11
people.
million people lives there. And of course, water resources is, of course, under pressure. And we're talking about water resources. We're not only talking about groundwater. Well, that's a very challenging for the government there to manage how groundwater and then surface water to supply all the 11 million people there lives there. But the issue is not only the quantity, but also the quality of those water resources. And then it's a fantastic job done by the government of Jakarta, having a strict regulation for the groundwater extraction. And then we haven't heard about the surface water. But yeah, I think everyone should understand as well how those resources should be managed. I think that's what I can throw to the audience here, what we have to discuss. Thank you.
Okay, thank you very much, Dr. Arianto, for your insight. And I think right now we can invite the speaker, Dr. Tarak Setiawan, to maybe address some of the just now those discussions contents. And in addition to that, I think just now, Dr. Jing, you have mentioned about like a request the presenter to share a little bit of information towards the ends of your comments just now. Yeah. No. You asked him for something just now, right? Can you repeat that questions or in a slow? Yeah. Thank you.
So thank you very much for the presentation. And I'm quite curious about some information you provide. So first, I would say firstly is about the nitrate pollution. So that value I see maximum around nearly 150, but that one is basically on the unconfined aquifer. So and basically that results is from the recharge zone. So if the groundwater use is decreasing, so that means the nitrate will stay in the groundwater for more long time, and with the time spent, the nitrate will just flow into the, how to say, the basin area. So is that some problem for the groundwater quality in the future?
Dr. Jing, so Dr. Tiat, can you address this?
Groundwater in just in Jakarta is experience a very significant decline, especially from 2009 until now. Of course, this related to strict regulation, and before 2023, the regulation on the provincial government, and now the regulation of groundwater abstraction on the central of government. And the strict regulation on groundwater extraction and increasing of groundwater tax in 2010 is significantly the decreasing of groundwater usage. And now Ministry of Public Work and provincial government also extensively taking development of drinking water supply system service area, and it will effective to the next period to to decrease the groundwater usage in the Jakarta area. And we will optimistic that the groundwater management in Jakarta could be recover the groundwater mainly in confined system in Jakarta groundwater basin. But the problem is quality, about quality in Jakarta unconfined aquatic system, that it related to geological problem or geogenic factor. I will ask also ask Mr. Professor Guangso, do you have how to effective reduce the anthropogenic contaminant, especially in area with low permeability such as Jakarta, and how effective infiltration wells could be improving groundwater quality. In the North Jakarta, the population is denser, but the nitrate concentration are low. Does anyone have experience with soil type or geological factor in minimizing the contaminant transport? Do you have experience about its situation, Professor Guangxi?
So, Professor Jing, so the Dr. Dea just asked you questions like, do you have any experience about the soil factors and contaminations related things? So, yes. Oh,
China, in China, and how do you have any experience with that? For nitrate, for example, so because the permeability in Jakarta soils, I don't really understand, but it affects the transportation of nitrate to the groundwater. So, do you have, or maybe Professor Chen, any experience? Yeah, and
In the north of Jakarta, the population is denser than southern part, but the nitrate concentration are lower than southern part. Do you have experience with soil type or geological factor that to minimize or reduce the contaminant transport at the natural condition?
Yeah, okay. Okay, hi. So I think it really is site specific, and in the area, like in Delta area, usually we have some kind of soil which is quite fine and or clay in the situation in the Delta area. But in the say the Laizhou Peninsula, which is in the south part of Guangdong province, next to the Hainan province, where the Dr. Jin's university is located. And in that Laizhou Peninsula area, and quite a lot of groundwater or are still being used for domestic water use and industrial use. And in that area, we have done quite a lot of research. And for some area, which is quite sandy, and we can see groundwater recharge rate is quite higher. And actually, we have also measured the groundwater age in that area. And particularly for the sandy area, the ground age is quite young. Means in this area, particularly groundwater recharge fast, and the groundwater is quite young. But for some coast area, and with some clay or some kind of much finer, some soil, and the groundwater is become much older in the area. So from the sandy area, it could be less than, it's about, say, 1,000 or 22,000 some areas in that area, in the sandy area. But in clay area, the groundwater could be as old as, say, 10,000, even more in that area. Of course, it really depends on the area, and say from the recharge area, particularly for the sandy area, but in the coast area where the groundwater is kind of discharge area, and the groundwater is much older. And regarding this kind of pollution, of course, in the sandy area, the groundwater could be easily polluted because of the higher recharge rate. And for some this kind of discharger with a more clay component, and the groundwater will be moved more slowly, and it's more, what I mean is it's much more, say, it's a little bit difficult to be polluted anyway, and means that for a sandy area could be a little bit more vulnerable to this kind of nitrate, some more nitrate or nitrogens or pollutions. So actually, it's quite related to this kind of, what I mean to say, is a nutrient problem or pollutions is quite related to the kind of soil permeability. Yeah.
Thank you, Dr. Cheng, for providing us about these informations. And in addition to that, I think Dr. Dad also wanted to know, like, is any kind of efforts that has been taken by the governments or taken by any parties regarding to that issues? Do you have any ideas?
And how about in
Administrations, I
I
think
will
it's
ask
still going
Anilat.
on. I don't think there's any, what I mean, say there's we have done some research, and the result of this research has not yet been, transferred to the kind of administrations for the management. I think there's still some ways to go further for this kind of connections between the research and the administrations or management.
Thank you very much. So, Dr. Dad, is that already answer to your questions?
Could you repeat the question, Miss Yu Ching? Sorry.
All right, thank you very much. So like just now, Dr. Arianto also mentions about like the situations in Japan. I think this is a very great chance for us to involve also the insight from a researcher from Japan. So since we have two professors from Japan right now, so let us invite Professor Hayashi to provide some insight from Tokyo.
Thank you for your presentation. I'm Hayashi from Akita University, Japan. I have studied the urban groundwater in Japan, and I studied in the groundwater environment in many urban cities in Japan, especially the Tokyo metropolitan area. So I would like to say some topics from my experience and Japanese governmental groundwater environment management. Today's your presentation, you showed us the monitoring system and the monitoring network in the Jakarta Basin. I think that is very great system and activities. But on the other hand, if we want to manage the groundwater environment, we have to consider both groundwater itself and also the hydrophysical properties of the sediment, such as the permeabilities and the hydraulic conductivities of aquifers and aquiters. Because if consider the scale of the, such as Jakarta Basin, huge areas, the groundwater must be required the long residence time to travel, to migrate the groundwater flow from the inland part to the coastal part. For example, in the Tokyo area, the groundwater age around the Tokyo Bay is the thousands of, or much more, the tens of thousands of years residence time. So I guess in the Jakarta Basin, the groundwater must have a very long residence time. So if the groundwater development change the groundwater flow regime, even though the actual groundwater traveling time not change because the hydraulic permeabilities are not changed after the groundwater development. So I guess we need to consider the hydraulic properties, evaluation of hydraulic properties of aquifers, and also, if possible, I recommend to evaluate the residence time of groundwater. This is one of my points. And the second point is, in many cases in Japan, the groundwater development induced the vertical groundwater flow between the aquifers, several aquifers, even in the different groundwater flow between the aquifers in natural condition. But the groundwater development sometimes induce the vertical groundwater recharge from the shallower aquifer to the deeper aquifers. So that is the affect both the quantitative and qualitatively groundwater environment, because as you mentioned, if the shallow groundwater recharge the deep aquifers, that means the contaminants such as nutrients or pollutants recharge to the deeper groundwater. So the connection between the aquifers is very important point. So I guess that as your presentation, there are some aquifers in the Jakarta Basin, but I think such kind of huge areas, the connectivity of the aquifers is not so continuous or stable. In many cases, the aquifers become thinner or sometimes permeability change. So I would like to say again that hydraulic properties is very important. So not only the aquifers, but also the aquifers. And the third point, in Japan, in many urban cities, after the regulation of the groundwater pumping, the groundwater levels has increased again. So the people want to use the groundwater again as the groundwater resource. So in that case, the Japanese government and the local governments consider how much volume can pump again. So the government have to decide the volume of groundwater. In that stage, also the government have to evaluate the groundwater flow and groundwater volume in the aquifers at present. So also in that case, the permeability and transmissivity of aquifers is very important information. So the groundwater level distribution is also very important, but also the hydraulic potentials or hydraulic conductivities or transmissivities are very important to evaluate how much we can pump the groundwater again. This is the third point. Okay, thank you so much.
Thank you, Professor Hayashi, for providing us with these three main points. And then we would like to invite maybe any open to the floor, like if anyone would like to answer to Professor Hayashi, including the presenters as well.
Okay,
I think I have
Professor.
some question first before we go to like, because actually I'm not
Thank you for-
expert in groundwater, but actually my PhD is to treat the groundwater contamination. We are using like permeable reactive barriers, but it's just that I wonder in Jakarta, Dr. Taat, is there any regulation
Yes.
in you like or any probably data like how many like what's it the wells from unconfined and confined groundwater, and what is the effects to the groundwater itself, you know, because like I think for confined groundwater is I think recharge much faster, right? Or I mean mistake. But if you have like extract more in the unconfined groundwater, right? You will lost a lot of waters, right? But in terms of confined, you can just extract more and more because recharge faster than the unconfined. Is there any effect in terms of land subsidence or in terms of that's why contamination? Because I saw the your presentation, if you extract more in the confined and then you have some what's it like space like without water, and then changing that conductivity in the what's it in the soil or mineral contained in that area in the feeder zone, and then I saw that there is a changing in terms of mineral, right? In the area, like more gravel or more sandy, fill that empty space when you extract the groundwater. Probably that's information is important, you know, that's why we have a lot of contamination. And I wonder whether we have more contamination in the unconfined or in the confined groundwater. Probably that. In terms of solving the problem, I think we have to solve on the surface because this is the transport from the surface runoff. So like from storm water, so we have to treat that water before it's transported to the groundwater. Thank you.
Okay, thank you. I will the number of monitoring wells in Jakarta and also the recharging well hasn't properly identified because the authority for groundwater management has recently shifted from region provincial governance to the central governance. The monitoring groundwater mainly in the groundwater level is carried out by the in the confined aquifer system because this aquifer system is dominant for the commercial use. The monitoring well in Jakarta with the new telemetry system only includes groundwater level, not yet the quality. This will plan for the future quality groundwater quality monitoring is carried out directly in the field. The aquifer recharge system in Jakarta hasn't been well identified, including the water balance problem. The hydrogeophysics properties, such as hydraulic properties, have also not been well identified, but now we optimistic that we can do it identify the proper physical properties of Jakarta Contour Basin because the currently groundwater regulation has shifted to the central to government, we can organize it better, including the accurate data for each of uh, commercial that apa pemohon itu apa namanya, the groundwater use in Jakarta have could we submit the accurate data for each to permit groundwater usage. Okay, jadi we will optimis in the next time to organize the groundwater in Jakarta better. But our management since 2023 shift from local government to central government.
Thank you, Dr. Dat, for answering the questions from Dr. Cynthia. So may I also invite Dr. Saito, Professor Saito, to provide some insight, maybe from Osaka Bay or the other area of Japan regarding to the same issue.
Thank you very much for your very nice presentation, Dr. Tad. And actually, I worked in Jakarta for several years ago with some researcher from Japan. And so today I'm very surprised because you already have a very clear groundwater conservation map. Of course, you didn't have that type of the regulation or conservation measure. So for more than 10 years ago, because I worked around 2006, 2007, and that period. So probably the lab subsidence was more severe at that time based on your presentation today. So yes, already Professor Hayashi give some information about the aquifer in Tokyo. And also we experienced the same situation, very severe land subsidence and seawater intrusion in Osaka area. But so as Professor Hayashi mentioned, so now the groundwater level already almost recovered. But so some area still, I think especially for the alluvial plain area, the subsidence has not recovered. And also the still some very high fluoride salinity and some contaminant was observed in the aquifer in Osaka. So that means the effect, the past effect of the significant pump up groundwater existing. So have a question. So do you have any evidence or the data of the change in the condition of groundwater salinization and contamination status? So did it change due to the recovery of groundwater level in Jakarta recently? Thank you.
So thank you, Professor Saito, in providing the informations and also asking questions. Dr.
Professor Saito. Okay, thank you for you. Okay. Thank you for your advice, Mr. Professor Saito. We know the Tokyo is geologically similar to Jakarta. I will ask you, based on condition in Tokyo, which similar to Jakarta, how much groundwater contribute to land subsidence, and what factor dominantly influence the land subsidence in Tokyo City, and what is being done to prevent land subsidence in Tokyo, Professor Saito. Could you tell me about the success story in Tokyo City to prevent the land subsidence? Uh, thank you.
Maybe about the Tokyo area, probably Professor Hayashi can explain better than me the success story of the countermeasure against the land subsidence.
Um, in Tokyo area, the Japanese government and the local governments restricted the groundwater abstraction by laws and ordinances in the end of the 1960s and the 1970s. That was based on the result of the observations of groundwater levels fluctuations and the groundwater levels. So the problems of the ground level depression, land subsidence has occurred much earlier time. But in Japan, the development of a monitoring system required very longer time. So the Japanese government could evaluate the actual problems and process of the land subsidence and groundwater depressions. So after that, the governments can make the regulation. So this is the relatively the usual cases in the world. So I mean the progress of the progress of the issues, groundwater issues, much progress earlier than the regulation of the problems by laws and ordinances. So in Japan, that requires about the delay of about 40 or 50 years. But I think in Jakarta or Indonesia, that you can regulate much earlier than Japan. So I think that you can learn from the experiences of Japan or other developed countries. I hope. Yeah. Yes.
Yeah, we should recover faster than what Japan experienced or another developed country. But of course, it's not that simple, you know. It's not just to adopt technology, but we have facing a lot of things, you know, culture difference, social, and of course, budget. That's
Very complex.
I had experience when I studied in US. See, I mean, we did this research remediation for groundwater contamination. How much money, you know, you have to, spend for that? Because especially construct the permeable reactive barriers, you have to like divert it the groundwater flow, and then you have to build this. But they're willing to do that. I mean, they have this, you know, in terms of money, in terms of it. But in Indonesia, that's very difficult. We're not talking about groundwater, just surface water, just for that. I mean, for just to provide the clean water. I mean, for this drinking water treatment plant, we don't have that. We don't. Not everybody has access on that. You know, so that's why we still have. We have to use that groundwater. I mean, no control on the extraction of the groundwater. That's a part of the problem too. How to manage all those things, how to control, and also how to control the pollution. I mean, so in terms of municipal treatment system. I mean, I don't know what is the percentage of that in Jakarta, but that's just in the big city. But what about other cities? I mean, so yeah, I mean, we hope that we can recover faster, but yeah, we don't have that thing. Thank you.
Thank you so much.
Thank you, Dr. Cynthia. So is there, can we get any insight from the China side, maybe Dr. Jing or Dr. Cheng provide?
Yeah. So actually, I think it will take quite a long time if I try to introduce some more information about the groundwater in China. And actually, I have done some research in the North China Plain, where the groundwater was mostly used in that area. And because a huge, water has been pumped from the aquifer, and the groundwater level so decreased more or less 1 meter per year in the North China Plain. So means about say 50 years ago, the groundwater level could be allowed 10 or 40 meter above sea level. So and the groundwater going down, so 1 year, so 1 meter per year. So it means nowadays the groundwater level is allowed 5 or 6 meter above sea level. So this is very serious in the North China Plain. So then the Chinese government decided already anyway, and initiate this kind of project of we call the water transfer project from the Yangtze River to the North China Plain. So every year around 100 million tons of water, surface water, was transferred to the North China Plain. So this project, I think, has already started more or less 5 or 6 years ago. And nowadays, so the groundwater level, so the situation of the groundwater level in North China Plain. So now you see that before the groundwater level going down 1 year, 1 meter, and now this the groundwater is more or less, stable, or called stagnant. Actually, it's more or less stable, but it's not yet for the recovery. It maybe take more long time for groundwater level to be recovered. So then say the Chinese government decided we try to regulate, or even for some places we have to stop and the groundwater use in particularly some coastal area because of some kind of seawater intrusions or some contaminations. So generally, the Chinese government have some regulation to stop groundwater use even in the North China Plain, but because that's almost impossible. Usually the farmers, they are using groundwater for pumping for the irrigations or whatever for domestic water use. So even for these farmers, it's not possible to stop. But for some kind of industrial water use, also some kind for domestic water use, so the Chinese decided to stop all this kind of groundwater use. For example, for even some for big cities like Beijing, I think say 20 or 30 years ago, Beijing also used quite a lot of groundwater. But nowadays, I think the groundwater more or less stopped in Beijing, also in some big cities in the North China Plain. And for the case in the Leizhou Peninsula, as I mentioned, so if you mentioned, and the Guangdong province also decided to stop this kind of groundwater use in the Leizhou Peninsula. So even though the groundwater use rate is what I mean is about total water use in the Leizhou Peninsula, I think it's more or less 25 or 30%, depends on groundwater pumping. So that's Guangdong province decided to stop all this groundwater use and try to have new projects to transfer some water from the Yellow River and to the south, to the west side, to the Leizhou Peninsula. Let's just try to change or replace this kind of groundwater use and to stop groundwater pumping, because in the Leizhou Peninsula, the groundwater level also is going down quite fast and cause quite a lot of problems like subsidence, like seawater intrusions, even some place we call depletion zones in Leizhou Peninsula. So I think this is the main policy that Chinese government decide to stop groundwater use and try to have some kind of shift, say from the groundwater use to surface water use. And so for some areas, like in one basin in Guangzhou, we call the Guanghua Basin, about the west side of Guangzhou city. And that area is basically, the bedrock is kind of carbonate. And if you use too much groundwater in that area, and the groundwater is going down, then it will cause no subsidence in that area. So I think this the Guangzhou authority and decide this stop groundwater use levels about in 1995. So already groundwater level is going up, and then there's still, of course, some subsidence. But I think the similar case is that in Tokyo City, if you stop the groundwater use and the ground level is going up, and which also cause quite a lot of problems. I think it's like the subway on the even I think in Guangzhou, maybe in Tokyo, and because of some what to say this one, this if the groundwater level is going up and you push this all the equipment, so the building is going up and need to take quite a lot of effort to push down. Otherwise, the subway system is going up. Then it cause so many problems. I think the similar situations. But I'm not sure in the Jakarta, you do have some subway system as well in Jakarta city. So it is going, the groundwater level recovered too fast, which will cause kind of a similar system. So buildings will be going up, will be push up. Then it got so many problems actually. And say actually in the coast area system, the situation is much more complicated as we expected. And usually we have two process. Usually this one, called the seawater intrusion. And in case you say the groundwater level is going down and the sea level is up, then that you call some kind of seawater intrusion. On the other way around, you have some kind of groundwater seepage problem. If the groundwater level is going higher than the sea level, and we have some problem with the groundwater called SGD problem, seawater intrusion. So in this case, I think as I gave a presentation yesterday, if much higher pollutions in groundwater, say higher components of nutrients, heavy metals or organics in groundwater, and because of this process from groundwater to the seawater, even to the seabed, will cause quite a lot of algae, bloom or kind of red tide problems. So, but actually, it's difficult to define some kind of area of the sea water intrusion. I think we have this kind of problems in some island in the south part of Guangdong province, and because they're using quite a lot of groundwater. But the real situation is not really, seawater intrusion as we explained. But the real situation is that you pump quite a lot of seawater for fishing, for the fishing agriculture in some higher land of the island. So if the island, the pumping of the seawater for fishing, agriculture, and then this seawater is infiltrated, and then you pollute the groundwater. So actually, it's not real, the seawater intrusion. In the seawater is higher than polluted. But actually, pumping the seawater in high area for fishing, agriculture, and this kind of seawater is infiltrated in aquifer, which will then polluted groundwater. So the real issue is not seawater intrusion, but actually it's kind of some human activity, the effect of human activities. So I really, prefer to define as a kind of seawater and groundwater interaction between when the tide is going up, then we affect groundwater level. In the sea, the tide is going down, then groundwater is going down to the ocean. And the intensity of interaction, actually, we have measured both and the tide level and groundwater level. And the sea actually, we have some quite similar, phenomena, some variations of ground level in response to tide changes. And how to define this kind of interaction zones, But actually, we have quite a lot of monitoring systems, from the coast area to a little bit further in the inland area. And we found that, this kind of interaction zones is at less than 300 or 500 meters. What that means from the coastline to about to the maximum 500 meters, you can find some signals which was affected by the kind of tidal changes. Beyond that, you cannot see any, interaction. So actually, this is kind of seawater and groundwater interactions, nothing to do with this kind of seawater intrusions or whatever. So we prefer to define it as a kind of interaction zone, not in seawater intrusion zones. And then the other things I think I have interest to share with you. There's one situation of we call it's not a pollution, but the source of some ammonia is quite interesting. And the source of this ammonia actually is not human source. What I mean here is like natural sources. And so we have done some research in groundwater. We call it a paleo groundwater. And groundwater is usually could be older than 10,000 years. And because of kind of the sea tide, no, it's not tide, it's kind of due to our kind of changes of sea level. I think mentioned by Dr. Dat. He mentioned around 9,000 years ago, the sea level was on the peak. Yeah, I think it's due to kind of some kind of in water and the land, some kind of changes. I know we have some process related to some we call LGM. It's last glaciation maximum, LGM, which took place around 20,000 years ago. I mean, the most glaciation that occurs in that area in that period. So it means at that time, say this 20,000 years ago, the sea level was much lower than the current situation, and around 100 meters lower than the current situation. So after that, the sea level is going up again, and until I think Dr. Dat mentioned about 9,000 years ago, the sea level was on top. But in the situation in the Pearl River Delta, we know more or less, around 6,000 or 7,000 years ago, the sea level was on top. So it means nowadays, most part of the urban area in Guangzhou was in the sea, inside the sea. And after that, the sea level is going down again. So during this kind of process, so much, organic matter remain in the land, and then we're covered by some kind of fine material on some sediment, which we know as a kind of aquitard. So in this situation, we cook quite a lot, this organic material was buried inside this area. So which, produce quite a lot of ammonia. So this ammonia is is a kind of natural sources because of some sea level changes going down and going out, to the land. So I have no idea, even in Jakarta Bay, you can find this kind of high ammonia area with, natural sources. And say in the parallel delta, we can even find this kind of ammonia source, which, the concentration could be as high as 500 milligram liter. It's unbelievable. So actually, it's nothing to do with the pollution. So I think we also to know this kind of, even it's possible to find this kind of source of ammonia, high ammonia in Jakarta. But I know in the Bangladesh, in the Ganges River, we also find quite a lot of this kind of high ammonia component, but it's due to the kind of natural process of natural sources, but not the source from the anthropogenic source. And regarding some kind of management, as I mentioned, the Chinese government decided to stop groundwater use. But actually, this reasonable or in terms of a scientific view, this is correct or not? Say, in the Leizhou Peninsula, if we stop this kind of groundwater use, and actually, it is quite costly. even I don't think it's economically reasonable economically, and say so we need some to argue that okay, why do we want to stop this groundwater use? Because this groundwater is infiltrated quite fast in this area, and we have done this kind of work in the field. We pump quite a lot of water because we need sample, we need clean water or some kind of a push of groundwater before we sampling. And we have dig a very small store, like the size like this, small like this, less than 1 square meters. And we pump quite several tons of groundwater before sampling. And we can see immediately, groundwater infiltrate immediately. We cannot see any, some groundwater or some kind of, say, runoff in the area. Groundwater so infiltrate quite fast. So it means in this area, it's not reasonable to stop groundwater use, because in the Lezo Peninsula, you cannot see any big river. It means in this area, the rainfall in that area is around 1,400 millimeter. I'm not sure that in Jakarta, quite maybe a little bit lower than the Jakarta area. But in that Lezo Peninsula, which has an area of around 10,000 square kilometers, so there's no any big river, means groundwater, is rainfall or infiltrate quite fast. So actually, the source of this groundwater is coming from the rainfall. So if stop rainfall, so use and then groundwater actually also from this kind of natural process, we are going to the sea to the. So what I mean here is scientifically, it's not reasonable to stop groundwater use, because actually groundwater is recharged, has been recharged, from the rainfall. This is the kind of natural process. So and then we need to argue that okay, if you want to stop, then we have to define how old groundwater should be, should be enough to be measured first. Then you decide to say, also okay, one this for the aquifer, which has a groundwater is about 1,000 or 100 years, even for some aquifers 10,000 years. So from this kind of research, I think we need to transfer some scientific knowledge to the groundwater management. Then we need to have some rule. Even I think internationally, actually, I have worked with some as a kind of we have a groundwater and climate commission under the IAH, is International Association Hydrologists. So I work as a kind of co-chair of this commission. We have 3 co-chairs for groundwater and climate change, and we need to have some definition, so to make sure, for those groundwater has younger age, less than 100 years or less than 1,000 years, could be used reasonably. For those of groundwater has more than 10,000 or 10,000 or even groundwater more than 1,000 years could not be used, could be stopped anyway. So I think this some kind of knowledge could be transferred to the groundwater, some kind of management. But internationally, I think it could be a little difficult. But I think if we try to do some things to push or to force some kind of regulations, and to say what I mean here is sometimes we have some meeting with some administration in Guangdong province, even we in some kind of national committee in China. So I argue that for those groundwater quite young, it's not reasonable to stop groundwater use. Otherwise, we try to have some project to transfer the water from the south and to the north, but also we have some project from the parallel delta to the Lezo Peninsula. As far as I know, the cost of this water transfer to the northern plain, I think this more than 20 or 30 years ago, the price for 1 cubic meter then was, I think it's more than 10 yuan. 10 yuan means around $0.50, something like the cost of this water transfer project from the north, from the Yangtze River to the northern plain. So for this kind of water, it's not reasonable. It costs $0.50 and use this groundwater for irrigation is ridiculous. Of course, this water is not supposed to be used for irrigation. It's only for industry and for domestic use. And for the cost of the transfer from the Piero River water to the Lezo Peninsula to the west side. And the cost and for this kind of transfer is allowed to say 40, I think now it's 40 cents of US dollar in terms of US dollars. But the real cost, actually ask some in the planning, some guy who is in the responsible for planning of this kind of project. And she told me that the cost could be allowed 0.4 cents in terms of US dollars. But actually, I did not believe that it could be so low. It could be much higher. Could be, I think, $1, something like that. So we use so much higher cost of surface water for irrigations in the west part, just to try to stop groundwater. I don't think this is reasonable economically and scientifically. I think more or less some comments.
Yes, so thank you. I want to say some comments. So in China situation, so normally the coastal area is maybe in the southern China is like basically the agriculture area. So in that case, so the very high, as we say, maybe the summer temperature is similar to Jakarta. So we have high temperature. So we have very, how to say, the good agriculture area. So maybe the decomposition of organic matter and some nutrient releasing into the groundwater is very serious. So we have done some survey of the coastal groundwater. So normally it's a few kilometers from the coastal line. So in that case, the residents people just claim that the nutrient concentrations is increasing and the water quality is decreasing. And formerly they use that water, for example, for irrigation is okay, but recently the salinity also increasing, so that one is not good. So then after that, we just measuring the water quality and we're measuring the bottom water quality. So we both can find very high, organic matter concentrations in the water. And we can estimate about 10%, over 10% of the river discharged organic matter in that area. So I think the similar situation from Jakarta and China. So because maybe we say the sewage and the people and some maybe livestock and agriculture, and the decomposition of the organic matter in the soil and produce like the nitrate and maybe dissolved organic matter is very obvious and strong. So that one will continuously contribute to the nutrient concentrations in the coastal area. So because like I presented yesterday about the Western Guangdong coastal area, that the coastal current will transport some nutrient, but during that process, the nutrient concentration is not so, rapidly decreased because there are still some small nutrient source contribute to that one. So it will continuously, flow to a very far place because of like the submarine groundwater discharge supply and some small rivers. And like also we said, after the raining event, so maybe the organic matter decomposition process is so quickly. So that one will quickly supply some material. So that one can, continuously affect the coastal environment. So I think this is also a very good point. I just share some one paper in the chat. So I think very good information if you can use. Thank you.
Okay, thank you very much, Professor Cheng and also Professor Jing. And actually, I just got an information that our presenter, Dr. Tat, need to leave at 11 o'clock. So maybe prior to your departure, can you give us some last comments or anything before that? Then or
before I will respond Professor Guangxi and previous I will ask Professor Jing and Professor Guangxi how long time in the groundwater level recovery in China? How long time the groundwater recovery after stopping groundwater use? And how much sea level rise in China due to the climate change? And how about the quality of the river water in China? Is it naturally good or any treatment to improve water quality? Because in Jakarta, almost all river water is poor quality. The government use water from the Jatiluhur reservoir in West Java is so far, the distance is so far as a source of clean water and raw water for the people of Jakarta. Thank you, Dr. Chu Yingli.
Thank you very much. So regarding to the questions from Dr. Tat, maybe Dr. Cheng or Dr. Cheng can answer it.
Groundwater quality or something?
Yes, actually I
How
couldn't.
long time groundwater level recovery since stopping groundwater use in China?
I think I say for very simple case studies we have done in the Guanghua Basin next to the actual part of Guangzhou city. So before 1995, the groundwater could be used was be used in that area, and that I mean this is a carbonated area, and after 1995, the groundwater cannot be used anymore. And actually, the groundwater quality was been changed. And before the pH a bit lower, I think less a bit lower because it's quite complicated, the chemical or some kind of process. And say before, I think 1995, the pH value could be around 6 or something a bit than that. So after the stop of the groundwater use and the groundwater quality has been changed a little bit. More firstly about the changes of the water level and the oxygenation reduction. Environment has been changed, and the groundwater nowadays is more or less being close to be 7. So I think this is a good situation. And say for the main groundwater quality issues in the coastal area, particularly in the Peroria Delta. And we do find the kind of groundwater quality mainly with the problem with the pH value. The pH is quite lower. Some maybe between the 5 or 6 in the most, quite a lot of area in the Peroria Delta. And the main reason for the low pH is something related to the acid rain. I don't know if the situation say here in the Jakarta area to have some similar acid rain, which will affect the pH value in the aquifer or not. And the second thing, I think in the Peroria Delta, we did collect, I think several, maybe more than 100 samples in this area. And the main source of the pollutants, particularly for the unconfined aquifer, is for the nitrate or nutrients or something like that. And the main reason for this kind of pollution is related to this septic tank. It's the leakage from the septic tank, and then which cause the high content of groundwater. So I don't know the main source of the let's say nitrate in the Jakarta Bay. Is that more or less related to the septic tank or some kind of leakages or not, or similar situation that in the Jakarta or not? I think that's the main comment. Yeah.
Thank you very
Jakarta
much.
also built a Jakarta sewage system. Okay, now Jakarta is developed the Jakarta sewage system that collected the raw domestic from septic tank to the collected to the Jakarta sewage system. And how about sea level rise due to climate change? The rate of sea level rise due to related to climate change in China is a high rate of sea level rise.
Yeah, but I don't think this can see clearly there's some impact of climate change on groundwater. Even though we have some kind of committee, as told before, the Civil Committee on the groundwater climate change, I think the situation I think it could be reasonable to do this kind of work in the North China Plain, like the arid or arid or the semi-arid, but in humid area like in Guangzhou, also in Jakarta area, we don't see any big changes of precipitation, and so even though in terms of the kind of say water balance, even though we could not see these changes of precipitation in the Guangzhou area, but we did see kind of reducing of potential evaporation. So if make simple calculation, if P precipitation equals to runoff and evaporation. So if more or less the constant of rainfall or precipitation, and if you have some decrease of evaporation, so it means maybe you have more runoff, even maybe you have a more infiltration. So theoretically, I think it's possible to have some higher infiltration rate, and because of the changes of or the reducing of evaporation. So I don't know the situation here, say in Jakarta, but in Guangzhou we calculated some potential evaporation, and we did find that this potential evaporation is going down. So it means that maybe higher infiltrations to the groundwater in Guangzhou area. But I don't know that in Jakarta you have a more or less a similar situation, say the decreasing evaporation, potential evaporation or not.
Okay, thank you, Dr. Cheng. So, Dr. Tat, is that answer to your questions? And maybe you can provide a little bit wrap up of your presentations.
Zoom or yeah.
He's leaving by.
Okay, but I think before you're leaving, I think give more comments. So not comment, actually, some information. And now next year, we are going to have a new project, which is working on the coast area, particularly on the interaction between the seawater and the groundwater. And this is quite big, we call program. So in the for the program, the funding is allowed, I think it's quite close to $2 million US. And I am in charge of one project, and the funding will be lent 1/5 or something like that. And we try to calculate some kind of flux, say from the coast area, from China, not only from the Pearl River, but the host even for the Yangtze River, for the Yellow River as well. And we try to calculate some kind of nutrient flux. Even we have tried to calculate kind of heavy metal flux from the inland to the sea. On the other way around, we could be also, we try to focus two places anyway. One is kind of, some pollutants, say heavy metals or nutrients or flux from the inland to the sea. On the other way around, we could also focus on some kind of seawater, some kind of intrusions, and say particularly from some islands, maybe you have some kind of some CVCs to the intrusions problem. The mainly you try to focus some kind of as well nitrogens flux from the inland. I think we can have some in the future, could have some cooperation if I have interest to have this kind of projects. So we try to organize some kind of international events or workshop. So all of you are welcome to China to have some cooperation research on this kind of influx of metals, heavy metal or nutrients from the inland to the sea. Yeah.
Thank you, Dr. Cheng. So, Dr. Tar, is there any input from you? Like maybe before you leave in 2 minutes, you would like to give some comments, the last. But Dr. Tar is going to leave in 2 minutes.
Pak Taat, sebelum leave, bisa tolong dikasih kesimpulan atau catatan penting dari kondisi Jakarta.
Okay, okay. Thank you very much. The Jakarta condition, no, the results of groundwater monitoring, so that there is a gradual process of groundwater recovery, mainly in a confined groundwater system, and also this is and the rate of land subsidence is decreasing. It is a positive indication of the result of groundwater management in Jakarta. However, we all must remain aware and continue to regulate groundwater use wisely and sustainable. And the suggestion and advice and opinion from the expert in this discussion is very helpful for me to manage the groundwater in Jakarta Basin in uh, next time better. Thank you very much for your suggestion, advice, and opinion for our institution. Thank you. Thank you. I will leave. I will other discussion to local government of Bekasi City. Thank you very much.
Thank you very much for that. Okay, well, Professor Onodera has just joined us no long ago. Maybe Professor Onodera, you could also add a little bit of insight regarding to just now those discussions topics, if there is any.
So sorry to be late, I'm not sure. So today's discussion, I think that firstly I just appreciate to this time of type of the discussion, but based on the government monitoring status in. Okay, so then also my question is this time already. Oh? Okay. So that later. Okay, so that this is just we are moving to the general discussion.
General discussions
Okay.
on the floor.
All right. So totally today's discussion, today's meeting is so nice and also so precious to our project, almost also the three countries researchers. So then finally we will discuss about the comparative aspect and in the future plan and also for the management. So then firstly, yesterday I talked about the nutrients, flux and marine species production, and also today and yesterday's somebody talked about the pollution issue and the nutrient issue in the land catchment scales, and also to the impact of some environments and sometimes the food productions. So especially in case of the Jakarta, so we can find that the fish pond is a so special land use rather than Japan and China. So that's impact already Anna introduced yesterday's presentation. Then, but based on her presentation, that the vulnerability is so high in Indramayu. So that meaning just I think that impact is based on that according to the fish pond impact, but sometimes we should also consider the topography difference and also the land use, another land use, and also the hydrological process in the catchment. But we should discuss what is the most high impact for the environmental vulnerabilities. So firstly, I have a question to Anna, so that which one is the most important, significant parameter and control factor for the vulnerability in the nutrient cycle and also the water resource? So first one, please say.
In my research area, or
Yes. Yesterday you were talking the three cities, the Jakarta, Mataram, Semarang, and Indramayu. So then your results, that conclusion is Indramayu is the most high vulnerable area. So then, but I think that result is based on fish pond land use effect.
so from yesterday presentation, I didn't distinguish the impact. I mean, the land use or other factor. So basically, it's simply about the water quality, so the salinity and also nutrient, and based on the results, so the main problem from the each city is different. For example, in Jakarta, the nitrate is higher than other cities. So the problem is mostly from nitrate, but chloride is also give impact in Jakarta, but not as higher as in Indramayu. So I mean, like in Indramayu, the chloride concentration can be 10 times or more than 10 times higher than in Jakarta. And just because of that one parameters, the water quality conditions make it very worse. So after including several parameters like nitrate, perhaps metals also, and also chlorides, and compared to other city, just because of chlorides, so it gives a very bad impacts to the total condition of water quality.
So then that means that fish pond, I think.
From this point, we are we consider that fish pond is the main issue, because as I think Professor Chen also mentioned about that. So it's not about seawater intrusion. So not seawater enter the groundwater, but seawater is invited. Invited to the land. So it's infiltrate to the groundwater. So it's probably one of the big issue, because the chloride content is very, very high. So people say that Jakarta groundwater is brackish or saline, or there was a saline water intrusion, but the condition in Indramayu is worse than that.
So then if the city, but also another way, so we also consider the population impact. So for my concept is just population increasing period is so high impact for the pollutant and pollution issues in the groundwaters, firstly. Then the first stage city, meaning rapid population increasing is totally affect to the pollution. But in case of the surrounding, also the expanding sea, for example, the Indramayu case is totally, that fish pond and food production is totally for the, not only Indramayu cities, but also the Jakarta, sometimes Jakarta, other cities to carry to the food. So then that meaning that we should also consider the totally land use change. So that one is also important. Or then in case of the more, not only city scale, but the island scale, that for example, the Java Island is, we can see that so many distribution of the fish pond in the coastal zone, that even the rural regions. So if that's your result is totally the high, good result for this, so fish pond impact is so big for the groundwater pollution for saline and ammonium and also trace metal. So that meaning, so we should expand to the island scales. So Java Island, how much we lost groundwater in with land use change from natural land to fish pond. So that meaning, so another issue, another the trend, another focus in the futures. But basically, we want to compare the Jakarta, Gonzo, and also Japanese series. So basically, that's comparison. So that meaning we also consider the climate and climate issue, climate characteristic difference. For example, that Jensen said already that Japan, Gonzo is sometimes the big rainy season, big rain by the typhoon. So that one is so big impact for the nutrient discharge to the coastal zones. So, but Japan and Indonesia is not so big typhoons. But also sometimes we have a big typhoon in Osaka also, but not so much. So that's different climate. Also, we should consider there. So basically, we want to characterize by the population change and also the infrastructures situations. So basically, we can separate classify the first stage, second stage, third stage. So that case, so that we can summarize the pollution status in each stage. But also we should add, because Professor Hayashi mentioned about the sewage system leakage is a so new pollution source in Tokyo. But also our observation also indicates the sewage leakage in Osaka is a so big issue. So then we also another stage pollution. So sometimes the sewage is so much species pollutant including. So we will consider also that Jin-san or Saito-san also mentioned about it. Okay. So now we will talk Japanese new issue and Chinese new issue and Indonesian side also the new issue. If you have another comment, so please discuss. Okay.
For Indonesian side, I just want to add that since Professor Hayashi has mentioned that possible leakage for another type of pollutants, I think in Indonesia is more than just nutrient. I mean, especially in the area with the, I think Iwan mentioned about also the contribution of paddy field. This paddy field is also still using pesticides. So you might also look at the pesticides in contamination in groundwater. If it's possible, also probably microplastic or micropollutants, right? I mean, in Indonesia, we already have a problem in terms of micropollutants in the surface water. So you might also look at that, you know. I know probably it's very expensive, I don't know. But I think in terms of microplastic, I can help. Or micropollutants, we can help too. Yeah, I mean, yeah, we should look at that, especially pesticide or organic pollutants, because I know I mean, some experience in terms of sampling of the some of the wells near the like a post paddy field, and you can see like this type of pesticides contaminate the groundwater. So, and also probably this is for Prof. Chen, that I didn't really get the answer from Dr. Tat about confined and unconfined. If it's Jakarta has to stop, we cannot stop the whole thing, right? I mean, for groundwater extraction, if we can choose, I mean, what do you suggest for Jakarta? I think we have to stop like unconfined groundwater extraction, right? Instead of what happened if we just extract from the confined? Is that problem with the seawater intrusion probably, or like we invite the, is it possible we invite, if it's the water, the groundwater level is getting low, are we going to invite the seawater to the groundwaters?
Hi. So actually, I don't know the situation in Jakarta, and we have several, have several aquifers in Zhanjiang, in Lezo Peninsula. Mainly, we talk about 3 aquifers. We call the unconfined on the top, and then we have a middle, and then we have a deep confined aquifer. So for the situation in Lezo Peninsula, and groundwater has been, exploited mostly from the middle and the deep aquifers. Means, say, less than 30-meter depth. In this, we have this top, and then from the 30-meter to the 200-meter depth, we call the middle, and the lower than 200-meter, we call deep aquifer. The groundwater is used mostly from this deep and the middle layers. So if you stop groundwater use in an unconfined aquifer on the top, because it cannot, what I mean, say the groundwater level is in the top layer, change quite fast. So in the dry season, you cannot find enough groundwater. So usually for some farmers, they maybe have wells of about 10 or 20 meters, and that's good enough. For irrigation, groundwater, or even for some city use, the groundwater actually come from the deep or middle layers. So if you want to stop groundwater use, mainly affect the middle and this deep aquifers. So if and I don't know anywhere the situation in Jakarta, if maybe it does not make sense to stop the water use unconfined. I think mainly it's from the deep and from the middle layers, which provide much more groundwater than the unconfined aquifer. And in terms of some interaction between groundwater and the seawater, and say we have some in the coastal area. I think it's 20 years ago when I was I moved from Japan to Sun Yat-sen University, and I was in charge when the experimental station just close to the coast area. We have some small research area around the 3 square kilometers. We have different groups of monitoring wells from upstream, downstream, and coast area. So totally, I have designed about 17 wells. In the coast side, I have 7 wells. with a different depth. We have wells of say 5 meters. We have depths of 8 meters, 10 meters, and the lowest one, the deepest one is around 35 meters. Means it's more or less in the close to the kind of the bedrock. And the bedrock in the coast area is in Guangzhou Imperial Delta is mostly granite. So in this case, the interesting is that for the unconfined low shallow aquifers, I could not see strong interactions between groundwater and seawater. I did find some very close relationship between the seawater and groundwater only for the deep aquifers, particularly for those two aquifers, about 20 meters and 35 meters. And we can see quite very strong interactions. What I mean is either tide level going up and going down, and can see clearly some evidence of the similar changes in these two wells. So in this case, if I want to see some more or less similar research in the Jakarta, I expect, more or less, I think the main situation, you can find some of a response of changes of groundwater only for the deep and maybe low and the middle aquifers, not in surface, not in the unconfined aquifer. Yeah, it could be. I think in follows in the deep aquifers, it can find a response. But for the surface, I don't think you can find this kind of response of some groundwater change to the tide change.
Real to 30 meter, but some around 60. But of course, deep well is mostly for business, right? Business area, hotels and things like that. But of course, the common is the major people that probably around 30 to 60 meters that gonna affect, right? I mean, if
yeah, and see. So actually, you want to do some research, for this kind of interactions. You need to consider some of the vertical changes, say for different layers. So usually we have some higher response of from the say deep aquifers. And the other things you need to consider as well as some kind of horizontal changes. What I mean here is distance to the coast area. So we find only some kind of response of groundwater level very, very close to the coastal lines. If we have a distance beyond more than 500 meters, I don't expect that you can find some response of groundwater changes. So for some very, very close, I think we have some wells in some island, very 5 meters, next to the coastline, and we did find this kind of very strong response of sea level in response to kind of also the groundwater changes in response to the sea level changes or tide changes. But beyond that, if you go further down to the inland, and you get less response of groundwater change, groundwater changes. Yeah. So I don't know. You have some the idea some the distance of this coast, how far is from the forest monitoring wells. So Indramayu or Semarang or Jakarta.
So for Indramayu case, for example, Chen Sensei, so we took several samples, but the effect of the saline groundwater reach more than, I think until 1 kilometer, 2 kilometers, 3 kilometers, still can find a very high chloride concentration. And for example, the Isivalu can reach 10,000 microsiemens. And even in some places, it can reach 20 or 30,000 microsiemens. It is higher than in the seawater itself. So we found that case during the very dry season. I don't remember the exact distance of the well to the But if you say about 500 meter, it's more than that. So can reach 2 kilometer from. That's why we suspect the activity on the surface. One of the cause with the groundwater salinity.
So for regarding the source of say this salinity is coming from the sea water or some kind of imported some seawater.
Exactly. So some people said it's a seawater intrusion, but we are wondering, is it possible if the location is about 2 kilometers from the seashore, the seawater intrusion? So, but in that area, they build brackish water pond. So we suspect that is the reason why the content of salinity is very, very high.
Yeah, but actually, I think it's also some kind of say that's some site specific. If the say permeability of hydraulic conductivity is higher, then it's possible, for groundwater to move fast. But usually the groundwater moves very, very slowly and horizontally. Mainly for K, horizontally is much higher than the vertically anyway. And in case of some study area in China, and we found that this groundwater move or at the speed allowed, I think it's allowed 30 meter per year. So usually it's very, very lower. So if I say you found some of seawater intrusions beyond 1 kilometer from the coastlines, so it means that if by assumption of say groundwater move, of a speed of 30 meter per year, so 1 kilometer it means takes more than 30 years. So it's not reasonable. Yeah. So in this case, so of course this site specific as I mentioned, if this is the K or some permitted is higher, the groundwater movement rate could be higher, but usually I think it's around 30 meter per year. So this is the main idea. In case of in the parallel data, we do find some kind of groundwater rate a little bit higher than that in Northern Plain by using the CFC, and the groundwater move could be allowed 100 meter per year. So even for this kind of rate, so 100 year per meter, for 1 kilometer, it takes at least 10 years, even more. So I don't think it's reasonable to assume this is kind of because to say, okay, seawater intrusions, and if thinking about some groundwater movement rate, so almost it's impossible anyway.
Also, we should consider the alluvium, the clay as saline, because that one is a marine sediments. So then sometimes the Jakarta and also in case of Osaka, that we have some result of the leakage from the clay. So we should also consider that's the from the layers. And also I want to ask the Professor Hayashi and Professor Mitsuyo Saito, so that how about the Japanese, the third stage, the city's issues, new issues? So probably yesterday you mentioned about that another contaminant and also the groundwater, something, also the surface water nutrient. Did you already talk?
Yes.
Comment? Already? Okay.
Before we move to the comment in this room, I saw a question in the chat box. So this question actually for Dr. Taat, but we don't have enough time to ask him.
Okay. So please.
So
maybe I can read out the questions and let everyone hear if you have any inputs to address it. So the questions is from Mr. Hidri Tresnadi, and it's about how can recovery of confined groundwater table occur? Is there leakage to groundwater table or pressure from the lower to the upper, or there's recovery pressure from the edge of the confined groundwater basin? So is anyone able to address this? Sorry, can you show Professor the questions? It's in the chat box, or maybe I can repost it again. I'm reposting the questions again.
We are discussing this question like we know all of the vocabularies, but we don't know the meanings. 単語は全部わかりますけれども、この意味は全然、私二人は全然わからないです。はい。しかし、
Mr. Hidi. Mr. Hidi Tresnadi, are you still in the chat room with us? Maybe you can re-ask the questions verbally, because I think all of us has difficulty in understand. Perhaps you can ask in Bahasa. We will have someone to help you translate. Mr. Hidi. I saw he's still in the chat room, but then, yeah.
Pak Hidir, maaf Pak Hidir. I think he's still in the Zoom.
Yeah, he is still in the Zoom.
Yeah.
I saw his name. Pak Hidil.
Maybe I try to explain a little bit. I'm not sure what the questions is, and if we wanted to try to control or to have some kind of recovery of the unconfined aquifer, say in some coastal area, like I think we have to do some measurement in the field. So I think also in Guangdong province, also in coastal area in Leizhou Peninsula, maybe 30 or 40 years ago, the ground, this is kind of artesian basin, yeah. So it means the groundwater level of this confined aquifer could be go up as far as maybe 3 or 4 meters above the land surface. So after 30 or maybe 40 years of groundwater, the groundwater level now is going down, maybe minus 20 or minus 30 sea level. So this is a situation in Leizhou Peninsula or maybe in other artesian aquifers. So you want to control this kind of say groundwater changes, you need to, of course, you stop kind of pumping from this aquifer, confined aquifer, then you could get kind of recovery of this kind of confined aquifer. And the most important things is you want to control this kind of thing, you need to some kind of zonations. What I mean, say to identify some of the source of the recharge area or resource of recharge zones. So particularly, I think in Jakarta, you do have some map. I saw that kind of map from Dr. Dart. You have some kind of recharge zones, which groundwater is not allowed to use, particularly in the north, in the south. So I think if we want to control this kind of confined aquifer, to make sure that some kind of recovery in the unconfined zones, you need some kind of protection or need to reduce of groundwater pumping in the recharge area. I think that's quite important things. And regarding the pollution, you need also more or less to identify this kind of recharge zones. If some recharge zone pollutions in the recharge zone, and it could go down quite fast, as I mentioned, in some area, recharge area, where it's quite sandy. Then the groundwater could infiltrate, the rainfall could infiltrate quite fast to the aquifers. So in terms of quality or the quantity, you need to protect all this kind of recharge area to make sure to have some kind of recovery and to make sure there's no pollutions in this kind of confined aquifer. I'm not sure that this is the answer to your questions or not.
So that case, so that we apply to the Bangkok and Jakarta. So then some researcher detect that some tracers. So that Hai Sensei also that very well know very well. So that for example, the Jakarta case that Professor Kagabu mentioned about that groundwater age in confined is totally the change to the young groundwaters. That meaning that the shallow groundwater leak to the easily to confined groundwater, even the low permeable the Akita. So then also the Bangkok that we have similar data and based on the oxygenating and also the dating data. So that case, that dating meaning that CFC value is totally only 50 years before ago. So then but even the confined groundwater we could detect that CFC values. So that meaning that groundwater is so young. But basically that confined groundwater has 10,000 and more than older groundwater age, but totally young groundwater age. So that meaning that easily leak even the low permeable clay layers. So that one is one of the mechanism of the groundwater level potential recoveries. But also some Hai Sensei yesterday talks small boys, but some borehole is sometimes leak to the easily. So that one is one of the big issue for the mixing of the contaminants intrude to the deep groundwaters. So I don't know that impact is the pollutant expansion and transport to the shallow to the deep. So, but that for that understanding, so we need to monitor to the more detailed, spatial, and temporal. So then not only just the main chloride and the nitrate, other species. So that other meaning that new issues in the future. So for example, that Hai-san talk about the new contaminants. So also if potential easily recover, so that meaning that another issue we have that contaminant easily to transport to the deep. So that one is also the bad scenario in the futures. And also we need to discuss about the management, how to manage of the groundwater and not only surface water. So then that one is a quantitative management is also the most important, but also quality. So that's meaning included the protect of the expand of the contaminant. So please discuss about that meaning. So, Sensei, please.
Yesterday I mentioned about the contamination by the domestic wastewater that contains the pharmaceuticals, PPCPS, and artificial sweeteners. And my colleague found the microplastics in the shallow groundwater in the Tokyo Bay Area. The size of the microplastic particles is about the tens of or hundreds of micrometers. So you cannot see and you cannot find, even if you touch the plastics. So the various kinds of the contaminants are increased in the shallow groundwater. And as for the PPCPS, especially the pharmaceuticals is used for not only for human, but also animals. So in the agricultural field, and if people use the pharmaceuticals for animals, then maybe that contaminates the shallow groundwater. So that's the one of the new problems. Thank you.
Is the research include all type of groundwater, like confined, upper, middle, and deep? Is it? Oh, and mostly which type of groundwater that you've found more contamination? Is that shallow? The shallow one, right? Is that the contamination?
Okay, actually, we also have another questions online. So let me read it out. Is there a technique or model that might be appropriate to avoid land subsidence, seawater intrusions, and tidal flooding on the north coastal of central Java, such as the Demak, Pati, Kudus area, which historically used to be the Muria Strait, which has now dried up? Thank you. So I think this probably involves some local knowledge of where's the area. Maybe someone can help to explain a little bit before all the other researchers able to understand.
Okay, maybe some comment anyway. Say for the technical model in regarding some kind of interaction between groundwater and seawater. And actually, there's only one, model, but, based on the kind of calculation, we have some kind of two models or whatever. You call one is a free flow, the other one is a model flow. But actually, this call for really depends on kind of some this numerical solution, and we use both free flow and model flow to calculate this kind of flux, or sometimes we calculate some water balance in the coastal area. And we have done this research in one Leso Peninsula, and for one PhD student, she is working on this kind of, but a little bit different anyway. But she, kind of defined one groundwater model from small basins, and then we have some kind of scenario. We say kind of in the future, maybe 100 years later or something. Then we can define some groundwater changes, groundwater level change in response to climate change. And the other student, MSc student, she's working on the kind of, say, seawater interaction in small island, in Nauru Island. And by using this kind of model, free flow model, we can calculate this kind of, say, water, some influx. So how much water, groundwater, is going to the oceans. So by using this kind of free flow or some model flow, you can have tried to do this kind of work. And actually, we also used thermometer temperature profile to do some kind of interaction between groundwater and seawater. And usually we can see this kind of profile of, say, we have a very deep wells in Zhangjiang or in Leizhou Peninsula. We have some groundwater level, which is depth around more than 300 meters. So in this case, we do find kind of groundwater change from the top and to the bottom. The temperature change around 10 degrees. So in this case, it means you have to go down 100 meters, you got, temperature increase around 3 degrees. So this is the normal, some rate of the groundwater temperature. But in some, strong interactions, say between groundwater and seawater, you could not find this kind of changes. But of course, it's also some kind of site-specific. In the carbonated area, we have also similar some, say, very, very deep monitoring wells, maybe 200 meters or something like that. And we did not find any changes of this profile. The profile of groundwater temperature is more than one straight line. So even from the top to the bottom, you cannot see the increase of some groundwater increase. So means it's strong interaction, maybe horizontally, maybe vertically. So you cannot see this kind of pattern. So I think this is also some technique you could use to define some some kind of interactions of groundwater and seawater. And the second, or maybe the third one, and we installed quite a lot of CTD inside this monitoring wells. I'm not sure you also installed CTD in this monitoring well. And then we also some the measurement from the tide. Then we can calculate or some kind of changes of both, this groundwater and the tide changes, even some quality. Actually, you could see some kind of response of, say, okay, groundwater level change, responding to the sea level change, but you cannot see any changes in terms of electricity on the EC. So it means a different story. The pressure is going down to the groundwater, but you cannot see the quality is affect some ground aquifers. So that is different story. So I think it's possible to use the CTD some kind of by installing this kind of equipment. You can analyze some interaction between seawater and groundwater. Yeah. I think the third one, or maybe the fourth one, and actually I think yesterday Anne and he gave some the presentation on some calculation, or estimation of some kind of nutrients in Jakarta Bay by using the remote sensing technique. But actually, one of my PhD student, he's working on some kind of estimated water quality. But nowadays for a lake. Later on, we try to also estimate the water quality in the coast area by using drone, not the satellite. We're using drone because the satellite, because of coverage, because of cloud, and you cannot use anymore. But in a small, particularly for a small scale, we have tried to use this kind of a drone to estimate the water quality, and the result is not so bad, and maybe it's good enough anyway. And the one publication is just accepted by the environmental pollution. I think it will be come down soon, maybe this week or next week. Yeah.
Can I add? Professor Chen, we are also developing a technique in monitoring water quality using our cell phone, so we can identify the color of the surface of the water, and then we try to take the result. I mean, getting the assumption that this color means to some kind of the level of nutrients. And then we had the algorithm already, so we used machine learning techniques based on 16,000 photos, and now it's still in development. On top of that, I want to ask whether if we have managed to reduce the source of pollutants, let's say nutrients, will the legacy of nutrients or contaminant will still affect the aquifer or the groundwater? That's what we see in the lake, or at least in Osaka Bay, where we have internal load. Will that also happen in the aquifer and then the layers on top or surrounding thing? So we have contaminants in our groundwater, right?
Yeah.
And then we have managed to isolate the contaminants and reduce the source. But is there still the legacy of those contaminants or pollutants that affect the aquifer or the groundwater? Let's say we have the same story in Osaka Bay, where we have internal load. That's because of the nutrients in the sediments comes up back to the water, right?
Okay.
So is there the same case in the groundwater? If you have removed all the source of the nutrients or contaminant, will the legacy of those contaminants or pollutants will still affect the aquifer or the groundwater?
So you mean some source in this area which continuously affect the.
Yes.
Yeah, sure. But I think it really depends on what kind of pollution you are talking about. So regarding the nutrients, because usually it's it can be dissolved in the water and it can be moved, at a speed more or less quite close to the groundwater moves rate. Of course, it really depends. Some kind of thinking about some diffusion or some kind of say absorption. So we need to consider all this kind of process. Even we need to consider some kind of denitrification, nitrification, all this kind of process is quite complicated anyway. And but basically, if we know some kind of say we call the groundwater flow field, means groundwater flow direction or the groundwater flow rate. So this is first two important factors to know. And if we know this flow direction, and if we know some kind of flow rate, more or less, okay, know some kind of groundwater will go in this direction and how far it will go per year, something like that. So this is for say nutrients, but for a heavy metal, usually it cannot be moved so far, and it really depends on the pH value. It's said you have some acid rainfall. So in this case, the heavy metal could move, at very, very maybe slow rate. And say for some research I know in city, in Fasan city is just next to Guangzhou city, and we did find quite higher contamination, less of say nickel. And I think it's cadmium or I think it's cadmium or chromium. Actually, it's chromium, not cadmium. It's chromium, and we still could not identify the source. It could be kind of some industry or some factories or some kind of industry, some farms which this land use is for particularly for industrial use both. So it was some kind of pollution, maybe 30 or more than that 20 years ago. And say in this case, if we want to identify the source or trace back, how far or what the source are for this kind of pollutions, maybe I think we have try to use some technique, some kind of say isotope for the metals. So in this case, we can identify more or less, where this nickel come from by using. We try to develop some methodology to analyze such heavy metals isotope, and to identify these kind of things. And the other things, I think we have developed some, not developed. We have done some project in one city we call Shenzhen. Shenzhen is just next to Hong Kong, and in some area, and this one built some the project which built quite a lot, for a new university, and they have some borehole, and from this borehole, they found this ammonia and phosphorus is maybe more than some 10s or 20s as higher as that, national regulation, limitations. Then the local government is really concerned where are the source of this kind of ammonia and the phosphorus, and they ask us, my group, to do some research and to identify the source of this ammonia and the phosphorus. And we have tried to identify so many possible, pollutant source. I think there's one vegetable area, agriculture area, and some could be some possible related to some septic tank, or could be related to some leakages of the sewage systems. And we monitor, this kind of changes of level of groundwater, monitoring wells. And we also measure this every 2 hours or 2 hours for the whole night with 20 hours. And we could not see some, variations like, ammonia. So it means it may be not related to the sewage system. If it's related to the sewage system, it could be changed. It could change like this one, but it's mostly constant. So in this case, it means maybe the other source could be possible. Then later we use N15 in ammonia. So by using this one, we know more or less the N15 of ammonia is more than 30 per mil. So in this case, okay, and then I know this some source could quite related to the pig, because of the pig farming in that area. But that was 30 years ago, as I mentioned, some kind of legacy. So I think by using this kind of technique, we identify, okay, this is some story. Then later on, we try to confirm this, is this true or not? And then we ask some people, say, okay, some who have lived in this area for more than 30 years. Then they thought, yes, that's true. It was some kind of pig farming area. So we just confirm this is a real story. Yeah.
Okay, thank you very much, Professor Ching, for addressing so many questions. And thank you very much for everyone for asking a lot of questions to make the discussions very lively. And since we are only left with 4 minutes to the end of these sessions, maybe we can invite Professor Onodera to give some closing remarks to this today's workshop. Closing remarks. We still only have 4 minutes.
Sorry, so I want to discuss finally so that about management, so that for example, the groundwater depletion, so sometimes we need to the artificial groundwater recharge, and also also that we have to control that pumping, but after that, so we need to control another way. So that one is sometimes artificial, and also that the urbanized areas is totally covered by the road and the concrete. So then that the groundwater recharge in the on-site in the city is totally decreased so much. So then if you have any idea to the management for the recharge and also the groundwater use and the water use, so please discuss. So then our in Japanese is that sometimes the groundwater management is a good example is Kumamoto. Kumamoto is totally the catchment scale management. Then the upstream zone is totally covered by the paddy field. Paddy is a good groundwater recharge area. Then, but normally in Japan, the summer season is only the cultivated, then the water ponded. But winter season, even winter, so then they ask the ponding in the waters for the not cultivate. So for the groundwater recharge, that meaning that just the management of the artificial groundwater recharge. So if you have another idea, so that, for example, Indonesia is a totally need to the new idea to the also the to the futures. So please, could you discuss finally? Thank you. Chinese side, do you have any idea on management? Firstly, Japanese ない。もう、はい、OK、OK。はい、じゃあ、レイト。
Yeah, thank you very much for all the discussions, and I believe you still have a lot of questions and maybe something that hold up that wanted to discuss in further. Perhaps we can still discuss after the sessions end. Thank you very much everyone for attending the sessions, and let's us closing this. Okay. To all the online participants, we are thinking to take an photos online through Zooms. So if it is possible, can you please turn on your video and we will going to take a screenshot soon.
No, two.
All right. Okay, thank you very much for everyone. So that's will be the ending of our sessions.